Hello everyone, let's now write a code implementation in Java for the bubble sort algorithm. Open up your Eclipse, then you can go to the file, new Java project, then we can name our project, let's name it bubble sort, then click the next, finish, and we can open up here our project, right click, and we're going to create a class. I will name my class main, and I will check here public static void main, so the main method will be auto-completed. Now first things first, we need an array. Let's create an array, we will name it my array, and let's say, for example, 88 42 to 1 minus 5 minus 77 69. So we just need to create a swap method first, so public static void swap, and as parameters we need an array, then two indexes. Now we can check first of all if the two elements are the same number. We have a stable algorithm, bubble sort is stable. So if the two numbers are the same, we just let them be, we don't swap them. Otherwise, we create a temporary a temp variable, and inside this variable we can save the first number. That means that our first number, which is stored inside the I, is now saved. We have saved it here, so we can swap it, and it will take the I plus 1 number. So we store the I plus 1, the number that is inside here, we store it inside the I, and then we can say array, and then we can say array I plus 1, and we can give him the number that we have stored here. But remember, I just wrote it down so that you can understand what we store where. Here we use a J, and this is our J. So now is our swap method ready. And let's go for the main loop. For the main loop, we start by creating an integer, a variable, and it will be I, and we will give it the myArray length minus 1, because don't forget that we start counting to an array from 0. So we want this number, the last element, as we stated in our slides, and the last element would be myArray length, which be 1 2 3 4 5 6 7 7 minus 1, because we start counting from 0. So 0 1 2 3 4 5 6. So it is the same thing if you write here 6. It's really the same. Let's do it with myArray point length minus 1, and we will continue that until it hits the start of the array here, and then we will decrement exactly like we stated in our slides. Now this is our outer or outer for loop. The inner for loop, the for loop that it will be inside, will be slightly different. We will say for integer j equals to 0, and we will do it as long as j is less than I, because we want to do it, the first traverse will be the whole, and the second one will be until here, the third one will be until here, and so on. You always go one element before this one, and then we can increment it by 1. Inside here we will say the following. Like we stated in our slides, we will check if the first element of the array, it will be the j, is greater than the second one, the next one. It will be the j plus 1, and if something like that happens, then we can use our swap method. The array will be my array, and then we will have j here and j plus 1 here. Let's print out our list, and we will go through the code for one more time. So this is good, my array length, this is also good, and now we can print it out. My array length, we can print it out by using the my array I, and let's make it a little more clear for you, and let's save and run the whole thing. Yes, let's do it with print. It will be better for our eyes, and as you can see, the array is now sorted. Now, before we close this video, let's check one more time the code. We first need an array. We have an array here with 7 elements. If we have an array of 7 elements and we start counting in every array from 0, then it means that every element that we need will be one smaller. So if we need the last element, it will be the element 6. If we need the first element, it will be the element 0. After that, we need to create our swap method. In our swap method, we first check if the two elements are the same number, because remember, this is the first element that we check, this is the second element that we check, and we say if these two elements are the same, then you can just return, which means just go on, and then is where magic happens. We store the value of the first element inside a temporary variable integer, then we replace the value of this element with the value of the second element, and then at that point we have this and this one are the same, and then in order to change the value of the second element with the value of the first element, we just give him the value of the first element that we have saved before, we have stored before in this temporary variable, and now we have our swap here. And then we write our loops. To write our loops, we just need the outer loop. In outer loop, you can just imagine that how many times do we want to loop here, and it is just so many times as the array itself, and we want to traverse this array from right to the left, so we count backwards. We start from here and then we at the next traverse the element here will be reduced, will be decreased by 1, and then we go here and here and here and here and so on. So we traverse it exactly the amount of times that the array is, that the length of the array is, backwards. So to the inside, to the for loop that is inside, we need to run it so many times, one element less each time, until we have a sorted array. And we say for every time that we loop, if these two are the same, we just pass. If the first element is greater than the second element, then swap them, and it becomes 43, 88. Then it will increment and we loop again, and you say if this element is greater than this element, then you can swap them. And this is what happens here, like that. Oh, here, like that. And then you at the next iteration, you check this one with this one. If the first one is greater, then you swap them, and so on. At the end, you will have your 88 here. And that's why at the next iteration, because we reached now one iteration from inside, then you go outside and you need to go -1 here, and then you iterate again and you say, is the first item greater than the second one? Then swap them. So this becomes 2, this becomes 43, and so on until it reaches here, and I will show you it is greater. And now you say, is the first one greater than this one? Then you say no, and then it goes further until you have here a 69, for example, minus 77. And this is how the array is sorted. You can also try my recommendation for you would be to write the same code at home alone and try to play with the code. For example, if you have here 1, 2, 3, 4, 5, 6, 7 elements and you need 7 elements -1, you can try it with the 6 number here and then save it and run it, and you can see if it works, if it still works. So you can play with everything here and try to understand exactly how the code works, because this one is the simplest sorting algorithm.